Right, guys. Answers to the end of chapter questions. So renewable energy resources, that's wind, solar, and geothermal. Um, Wind, because the air continues to move because the sun heats up the ground and then causes updrafts, and that's not going to disappear. We're assuming that the energy from the sun is going to be around for a very, very long time. So we assume that is renewable. Geothermal, that's renewable because we throw water down into deep pockets of hot rocks, and that comes back up as steam, and we can reuse that water over and over again. And these rocks are going to remain hot for a very, very long time indeed. Okay. Now, question two. State which definition of power below is correct. So if you look back at your notes, it's the energy transferred per second, not per hour. It's to do with how quickly energy is transferred. Okay. And it's per second. That's the definition. Power can be written in kilowatts, watts, kilowatts, watts. That's a symbol for watts, kilowatts. That's a symbol for kilowatts, and that's watts. All of that's just energy. These are all joules. Question three. So here's an experiment. We did something similar in lesson where we had potassium permanganate, this purple stuff that this question's purple color is potassium permanganate particles, and we had in water, we had that tube where the potassium permanganate moved, if you remember. So it says, describe what will happen to the purple color during the heating. So the purple color is going to move up to the top, and then it's going to come back down. Okay, I've actually answered this incorrectly because I've explained it rather than described it. Describe doesn't means do not give me a reason. Just tell me what you see. Okay, so describe what happens to the purple color. Ignore that answer for a second. So the first mark will be the purple color begins to rise towards the surface of the water, and then it will fall back down towards the bottom, and the cycle will repeat, and eventually this water will turn in, all of it will turn purple. And that's the description. Explanation, that's this entire thing here. So the thermal energy converted to kinetic energy of the particles. So the heat energy from the Bunsen burner is given to the particles. That is in the form of kinetic energy. The purple particles will gain energy and become less dense and rise up. As the particles rise up, they will be far from the heat source over here. They will cool, become more dense, and fall, and the cycle repeats. And this is what we call a convection current. So, this entire answer is the answer to B, description. I've given that to you verbally. Question 4. Name a fossil fuel that can be burned in a power station. Gas, coal, or oil. Explain why this is called a fossil fuel. Right, plants, animals, sea creatures have decomposed and subject to high temperatures and pressure deep underground for millions of years, and eventually we produce these fossils, and that's what they are: plant remains of plants, animals, and sea creatures. Deep underground, squashed over many, many years, and they produce this fossil. Use your answer to part B to explain why fossil fuels are non-renewable. Now, you just said they take millions of years to produce, so that means that whenever we use them up, it takes seconds, minutes, and it will take millions of years to reproduce those. So it will take millions of years to reproduce the same fossil fuel that is burnt over a couple of minutes. Okay, so that's why they are called non-renewable. Question 5. A tennis ball has 10 joules of energy when it is 1 meter above the floor. Now that's a gravitational potential energy. So just before something falls, it has gravitational potential energy. Now part B is up here. It says, explain why the student has made the statement of that the 10 joules of energy is converted into kinetic energy. So it states that there will be 10 joules of kinetic energy just before it hits the ground. So all that GPE that the ball had to begin with, that was 10 joules, is converted into kinetic energy of that ball. That's what the student is trying to say. So all that GPE that the ball had initially is converted into kinetic energy. Says, explain why the student might not be correct. That should be 5B part 2. So that there is 5B II. Okay, so why are the students not correct? So when the ball is falling, it originally has 10 joules of energy. Now, some of that energy is going to go as thermal energy, i.e. air resistance, as well as kinetic energy as it starts to move. So maybe, let's say, 1 joule of energy is gone to heating up the air, and then 9 joules has gone up to speeding that ball up as kinetic energy. Okay, right. Part C, explain why the ball moves. Okay, now we've kind of explained that through our answers here. So part C, what we are doing is we are explaining why the ball moves in the first place. So when an object is in the Earth's gravitational pull, it has gravitational potential energy. So we could say the ball has gravitational potential energy, therefore has the potential to move.